All right, here we go. One better. I know, sorry, I should have recorded the other part too. You see that -8 cosine and that 3 sine? We're going to do this without any formulas. I'll show you the formulas. They're down there. So check it out. What do I want to do? I want to turn these two into one single cosine with a phase displacement. So here's how I do it without formulas. Here's how we all do it without formulas. You see this -8 in front of the cosine? So pretend that -8 is like an x value because it's in front of the cosine. And that 3 that's in front of the sine, that's like a y value. So I'm going to exaggerate quadrant 1. So here's me exaggerating, well, not quadrant 1, quadrant 2. Here's me exaggerating quadrant 2. I'm going to put -8 like this. So this distance is -8. And I'm going to go up 3. That distance is the y value. Are we okay with that? The values that you want, go to the origin and connect those two. You want this value, that's going to be an amplitude, and you want this angle. Are we okay so far? Nothing crazy, right? So check it out, guys. Here's how we're going to do it. I'm going to get the amplitude of this. So I'm going to go amplitude equals, that's just Pythagorean theorem because I have a right triangle. And I'm going to go -8 squared. You can actually take out the negative because negative times a negative is a positive anyways. 3 squared. 8 squared is 64. 3 squared is 9. 64 plus 9, that's 73. So square root of 73. Leave it alone. Don't break it down. Okay, now check it out. I want this angle. So I'm going to find the reference angle. Theta r. You can always find the reference angle by just dropping the negatives. So I'm going to go arctan. I'm just doing SOHCAHTOA. SOHCAHTOA. Chav, can you use arc sine or arc cosine? You can, but I don't want to mess with the square root of 73. I just want to mess with the numbers they give. I just want to mess with the numbers they give me. Arctan of opposite over adjacent. That's going to be my reference angle. I take my calculator. Oh, let me put it in degree mode. It's going to change my. Oh, that's fine. I'll change it in a little bit for you guys. Mode. What did I say? Degree, right? Degree for now. Once we're super beast, we'll go back to radian. Arctan of what was the number with it? 3 over 8. 3 over 8. Arctan of 3 over 8. That's going to give me a number in quadrant 1, but I don't want that. 20.556. That's this right here. 20.556 degrees. If I want my angle in quadrant 2, I got to go 20.556 degrees. I got to go 180 minus 20.556. Yay or nay? Yay or nay, guys? Yay, because that's how you get quadrant 2. So let's see what this answer is. So 180 minus that. 180 minus this. 159.444 or 159.4439. Yeah, 4 degrees. All right. So here it is. Here's my equation. Y equals square root of 73 cosine, and I'm going to write theta minus 159.444, put the degree symbol, close it. This, I'm saying, is the same as this. And we're going to find out if that's true right now. You guys ready? I can see your pencils moving, so I'll wait a little bit. All right, check it out. I just changed my mode to degree mode, so I need to make this back to degrees. So let me make sure that it looks like the same one that we just had a little while ago, but in radian. So instead of going 0 to 2 pi, that's what this is. I'm going to go 0 to 360. And I'm going to put an x scale by every 90 degrees. Now, we should technically get the same graph that we had last time. Yeah, there it is. It looks exactly the same. Nothing crazy, right? So now look what I'm saying. Y equals, I'm going to go to Y4. This is, I don't know what color that is, pink. What I'm saying is square root of 73. And then it was cosine. I can't do anything right today. There we go. Square root of 73 cosine x minus, can you give me the angle, guys, that I put in there? 159. Like that? All right, so here we go. Yeah, that's why it reminded me of that. All right, so what I'm saying is this black line and this pink line, that pink line better overlay on top of the black line. Do we see that? Let's see. Well, I don't know. We're about to see it. Let's see if it's true. graph. Look at that. It's the same wave. So now you know the math that Drake knows, that Taylor Swift knows. Maybe they don't know how to calculate directly, but they all know, like, if you have two different sounds of the same frequency, they blend to create one unique wave with the same frequency. Isn't that cool? You guys don't think that's cool? Okay. Here are the formulas, guys. Notice I didn't even mention them. Notice, Chop, how do we do this again? Look, we did it by creating a reference graph. Whatever's in front of the cosine is like an X, quote unquote. Whatever's in front of the Y, the sign is like a Y, quote unquote. Draw your graph, and you can create your single cosine with a phase displacement. Make sense? Don't worry, we're going to try it 2 more times so you guys can see. Flip the page. We're going to do this 2 more times. I have this 2 waves, cosine and sine. I want to create one single cosine with a phase displacement. Here's how you do it. Ready? That 4 is in front of the cosine, so that's like an X. That 3 is in front of the sine, so that's like a Y, quote unquote. No, Yanni, that's a demerit. Next one's 2 demerits, and then 3, and then, okay, I'll stop. Here we go. First quadrant. 4, 3. I know some of you already know what's up. I connect from the origin to that. That's a right triangle. This is a 3, 4, 5 triangle, but if you don't see that, it's okay. I get the amplitude by doing the square root of 4 squared plus 3 squared. Square root of 16 plus 9, that's a 25. And the square root of 25 is 5. So there it is, just in case. Now I'm going to figure out what this angle is. So Katoa, I'm always just going to use the arctan. Why do I always use the arctan? Because I want to use these numbers. I guess you can use the 5 there because it is a perfect integer. So I'm going to write arctan. This is the angle I want. So it's going to give it to me immediately. Arctan of 3 over 4. I take my calculator. And I'm going to go arctan, second arctan of 3 over 4. And I push enter. And there it is, 36.869 truncated. 36.869 truncated. Put a degree symbol. That's the answer I want. I'm already in quadrant 1. That's the answer I want. So here we go. Here's my equation. Y equals amplitude 5 cosine parenthesis theta minus 36.869 degrees. I truncated it, guys. If I would have rounded it, it would have been 0.870. And that's it. If you want to test it, you can put this in Y1 and then put this in Y2, and they should be the same graph. Matter of fact, let's do that one more time just so we can make sure that they are. So look, I'll go to Y. I'm going to clear everything. Clear, 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 clear. On Y1, I already forgot the equation. Was it 3 or 4? 4 cosine plus 3 sine. So look, 4 cosine x plus 3 sine x. And then on this one, I'll put 5 cosine x minus, and I already forgot. What was it, guys? 869. Okay, check it out, guys. Window, and let me go from -5 or -7 to 7. -8 to 8. I guess it didn't make a difference. I could have just graphed it. All right, here's my Y1, and look at that. Y2 is the exact same. Cool or not? Yeah, so now you know. Now you guys are all professionals. Let's try the last one, and then we'll set you guys loose. So here we go. Not that you guys aren't, you guys, there's America. You can do whatever you guys want. But, okay. So here we go. I'm going to do a grid. That -15 is like an X. That 8 is like a Y. So I'm going to exaggerate quadrant 2. So -15, I'm going to say that's -15. If not to scale, I'm going to say that's 8. And what I want is the distance from the origin to that. That's my amplitude. There's my angle. Here's the angle I want. Here we go. It is a Pythagorean triplet, but if you don't remember it, that's fine. 8 squared plus parentheses -15 squared, and I believe you're going to get 17. So that's my amplitude. Now, how do I find my phase displacement? I'm gonna do arctan. And I'm going to find my reference angle. So I'm going to find this one right here. And then whatever, I know I'm in quadrant 2, so I'm going to subtract 180 from that reference angle. So here we go. I'm going to go arctan of 8 over 15. You can put the negative if you want, but you're going to get a negative answer. I guess you could always take that answer and add 180, but I'm going to do the reference angle here. So 8 over 15, so here we go. Arctan, so second quit. Arctan of 8 over 15, enter. 28.072. So 28.072 is this one right here, 28.072. The way you calculate the blue one, you just go 28.072. You just go 180 degrees minus 28.072. If you were in quadrant 3, you would add it, right? 180 plus that. All right, so here we go. I just take my calculator. 180 minus, and I scroll up. Enter, enter. 151.928. 151.928 degrees. All right, we got everything, guys. Y equals 17 cosine parenthesis theta minus 151.928 degrees. And you can check it by putting it in the calculator. How do we feel, guys? All right, so that's it. That's all we're doing. You're just doing this over and over again. And yeah, we're good for the day. Cool, right?